Hello again, welcome to video 3 where we're going to look at ionic compounds. What do we mean by ionic compounds? Well, that's an actual topic that we're going to spend a lot of time in later on, but we're just going to touch on today. So what do we mean by ionic compounds? Well, ionic compounds are compounds that have ionic bonding, and they are produced when you have an electrostatic attraction between ions of a metallic atom and a non-metallic atom. Basically, what I'm trying to say is, or what this is trying to say is, you have two ions. Remember how we formed ions? Ions are when you have a neutral atom and it gains or loses its valence electrons, so it can become positive or negatively charged. And if we know anything about electrostatics, which you may or may not, negative and positive charges are attracted to each other, and so these ions, which are atoms that have charge, are attracted to each other, and that is what makes an ionic compound. And we'll look at this in a way more detail later on, but that's what we're looking at here. And so the important thing about ionic compounds is charge, making sure the charge balances. Now these are some common examples. For example, salt, there's a common name, systematic name, formula. What's it used for? Sodium chloride, NaCl, sodium carbonate, Na2CO3, sodium hydrogen carbonate. So they get complicated formulas, some are complicated, some are easy. Calcium oxide, okay. These are all things that we've used. Anything you might have used. If you had an upset stomach, you might take some magnesium hydroxide, and that upsets your upset stomach, because usually an upset stomach is caused by too much acid, and this is what's called a base, and it cancels each other out. If you bake a cake, you're going to use baking soda, and that's sodium hydrogen carbonate. So they're just some common ones. Okay, now the first thing we're going to look at are called binary ionic compounds, and we mean by binary means that it only contains two elements. So we have a positive atom, which is an element, combined with a negative atom element. And we would use these terms cation and anion. And what do we use these for? Well, the negatively charged ion is called the cation, and what did I say there? The positively charged ion is the cation, and the negatively charged ion is the anion. Sometimes when I make little mistakes like this, I just carry on. Hopefully I correct myself, because sometimes it's just not worthwhile making a whole new video for a little mistake. So hopefully we understand that a cation is the positive ion and an anion is the negative ion. Now they're terms that we use occasionally. More often we just say the negative ion and then the positive ion. So now what we try and do is we try and determine the lowest whole number ratio of these ions that will give us what's called a net charge of 0. So basically we want to get the positive ions and the negative ions so that they cancel each other out and there's no charge, and that's an ionic compound. Now in the binary ionic compounds we only have two things to worry about: the positive ion and the negative ion combining. Let's do some examples. One technique that we're going to show you is the crossover method that we use to work out this lowest whole number ratio. Now, where do we get these ions from? Well, on your formula sheet you've got a table of cations, and if you forget what cations means, it's here, positive ions, and they're in columns. So these are all positive +1 ions, +2 ions, +3 ions, and +4 ions. And these are the only ions we're allowed to use in tests and exams and things. There are other ones. If you look in your textbook, there's a slightly different table, but these are all common ones that we'll be using. And so that's on your information sheet, and you'll get to use that quite a lot. And so it gives you the name and then the symbol, and notice that when it's plus, you can just write the plus. I sometimes write +1 just to, because that's how I was taught. And some people write plus, like here, +2, whereas here they've gone 2 and a plus. don't get too stressed about which one is which. Again, it's there's no rule. It just depends on how you were taught, really. Now, there's also the negative ions, the anions, and you'll find these in your formula sheet. Now, notice that only some of these are single atoms. A lot of them are these guys, which are made up of bundles of atoms, and these are called polyatomic ions, and you'll be looking at those in another video. So don't get too confused by these ones. We'll talk about those later. So what's the crossover method? Well, let's do aluminium sulfide. Aluminium sulfide. So we go to our table and we see that aluminium is +3, and we see that sulfide, we look it up in our table and we see that sulfide, we can find it if we go back. Let's just take you back. Where's sulfide? It's not in there. Okay, there it is there. Now look out, there's a couple of other things that are very similar names to sulfide. You have sulfate and sulfite, but we're after sulfide, and so this is just a sulfur with a -2 charge. So just be careful, be on the lookout, and that's where we get it. So we get our two symbols, aluminium 3+, sulfur -2. Now the crossover method is this. You take this coefficient here, or this multiplier, or this number, let's call it number, +3, and we bring it down to here. Alright, we don't need to show the charge anymore, we just bring it down. Now this is part of the process. We're not actually going to end up writing these numbers, or some of these numbers. Then we take the 2 and we bring it down to here. Now what we've done effectively is we've worked out the common multiple, because here you've got 3 times 2, which will be 6, and here you've got 2 times 3, which will be 6 as well. Now this will be -6 and this will be +6, but they cancel each other out, you see. And so these numbers here, which we've now used, let's get a colour, alright, become our multipliers for the atoms. So we need 2 aluminiums and we need 3 sulfurs. Now once we've done that, once we've worked out what our multipliers of each of the atoms are, we don't need to show the charge anymore, and so that will disappear, hopefully. And the formula we write for aluminium sulfide now is Al2, these are subscripts written down below, S3, and there's no charge because now the charges cancel. Alright, so in the working out process we might show charges, but when we are asked to write the final formula, we do not show charges. And so sometimes students get a little lazy and they just leave the charges up here because that's part of their working out. But if a marker sees charges on a ionic formula, it's marked as wrong. Let's do another few more examples. Writing formula for binary ionic compounds. Here we have some compounds: magnesium oxide, potassium oxide, and aluminium sulfide, which we just did. So look them up in your table. Alright, now if I use the crossover technique, okay, let's just do it for one. Let's get a colour that's a bit easier to see. Let's just do magnesium oxide. Magnesium, if we look it up in the table, is +2, and oxygen is -2. So if we use the crossover technique, that would tell us that we need 2 magnesiums and we need 2 oxygens. And so if I was to rewrite this formula without the charges, I'd go Mg2O2. That's correct, the charges cancel, but the next step that you have to do is recognize that these two are common multiples, and so the simplest possible ratio of magnesium and oxygen is not 2 and 2, it's actually 1 and 1. And so we don't have to write the little invisible ones there because the symbol does that for us. And so that would be the answer using the crossover technique. Alright, let's get rid of this. Let's make these appear. Now, what we're going to walk you through here now is a different way of doing it. And the different way of doing it is to have an imaginary set of scales. And the imaginary set of scales has your positive ions on one side and the negative ions on the other side. And the idea is, with your imaginary set of scales, you balance the charges. So this is this. You write your ion, magnesium and oxygen, +2, -2. It balances, therefore the formula is 1 magnesium, 1 oxygen, written like that. Pretty simple technique. What about potassium oxide? Well, potassium is +1, oxygen is -2, so to get +2 on this side you need 2 potassiums, and so the correct formula for potassium has to show these two, so it's K2O. Got that? What about aluminium sulfide, which we just did with the crossover technique? Again, trying to balance, so the magic number here was 6 and 6, so 2 aluminiums and 3 sulfides. And that's how. So different students use different ways. Some students use the crossover technique, some students use the imaginary balances. Your choice. Whatever works for you. Now, naming a binary ionic compound given the formula. So we have to go the other way as well. If we're given the formula MgF2, what is its name? Well, the simplest thing is the first letter is the cation, and that's the metallic element. And so that's going to be magnesium. That's why we need to remember our periodic table. You could look it up on the periodic table, but that's okay. Then we add the name of the anion. So there's two parts to this. Alright, there's the name of the metal, and then there's the name of the anion. And so we've named this as magnesium. I might change that colour, it's a bit dull. And then we need to know the name of F2. Now the 2 is just a multiplier to make the formula balance. So what we're looking at is fluorine, and what we need to go is, there's two ways of doing it. You can recognize that it's fluorine. F is the symbol for fluorine, okay, but because it's in an ionic compound, we get rid of the ene and we replace it with fluoride, which you've probably heard of. And so this would be magnesium fluoride. The other way of looking at it is go looking in your table of anions for F, and you will see that it's in the table of -1 ions, and it's given the name fluoride. So there's two ways of doing it. Right, let's get rid of that. So again, these are questions that you'll do in class. You'll get a copy of them, or you'll do them out of your textbook, and we should be able to do them. Just one thing, phosphorus is not on your information sheet. It has a charge of -3, and then you'll be able to complete this table too. So we get a bit of practice at writing these binary ionic compounds and naming them as well. Right, that all appears. Then you've got to name them, and then you've got to name them. So we get a bit of practice of that. Alright, now in the next video we'll look at what happens when we have these tricky guys called ions of variable charge and how we cope with that. See you later.